This is the warm-up for lesson 31, piecewise functions. We want to graph these functions, so let's graph the first one in green. And so my y-intercept is 5, and our slope is 3, so we're going to go up 3 over 1, down 3 left 1, oops, down 3 left 1, down 3 left 1, and we've got the line. We'll do this next one in blue. Y-intercept is 4. Slope is down 5 over 1. Down 5 over 1. We can go up 5 and left 1. And we've got our blue line. Now we're going to graph these next functions on a number line and on the coordinate plane. So graphing this on the coordinate plane would be, this is all real numbers less than or equal to 2. It's an inequality. Remember, when we have x with no y, that makes a vertical line. I have the equal symbol, so that's going to be a solid vertical line where all my x values are 2, and we're eating the 2, or it's open to the 2, so that means we're less than. So what are x values that are less than? We would be shading the left side of this line. For our other one, we've got a vertical line at 4. We don't have the equal sign, so we're going to do a dashed line. And we're eating the x, so we're greater than 4. So that means I'd shade on that side. So what does that look like? Back to our purple one. On the number line, remember that's going to be a closed circle, and less than goes to the left. Notice how we had a closed circle, that means a solid line, and we shaded on the left. Closed circle going to the left. And our orange one, open circle, and we're going to the right. Notice on our coordinate graph we were a dashed line, and we shaded on the right. Homework questions we'll do in class, and today we're going over lesson 31, graphing piecewise functions. So we're going to use what we just did, understanding what our constraints are to graph these functions. So we'll just take a look at this function. We'll call this top one. This is my blue function. So we're saying f of x equals 3x minus 7, and our constraint says for x values that are less than or equal to 2. So if I were to graph this constraint first, that would be a vertical line at 2, and we're talking about values that are less than, so we'd shade everything over here. So let's graph this equation. F of x equals 3x minus 7, so we'd put a point at negative 7. And our slope is 3, so we're going to go up 3 over 1 and up 3 over 1. Now, at this blue line, because our constraint says we just want x values that are less than or equal to 2, when we get to 2, I'm going to put a closed circle, and that represents that this was that we had the equal sign here. Okay, so really my graph doesn't include this vertical line, but I'm just showing it to you so you can see it. Okay, so that's what we're talking about. I don't need to keep on going up 3 and over 1, up 3 and over 1, up 3 and over 1, because my constraint says that I only want x values that are less than or equal to 2. So let's look at this other one. So this is just that. What I'm leaving is the only thing we need to graph. So the other one, we'll call it our orange graph. And our orange graph, our constraint is the same line, but now it's a dashed line. Okay, it's a dashed line. And we're talking about just values that are greater than, so just values to the right. So that will remind us that we're just going to the right. What's our y-intercept? Is at 6. So I'm going to put a point here at 6, but is that value to the right of 2? No, but I need it because I need to be able to know where I'm going to move from there. So I need to go, okay, so I'm going down 2 with my slope. I need to know where am I going down 2 from. So I don't need this point either, down 2 over 1. But my next one I am going to use. And so it's at 2, so I'm going to use an open circle. And then I'm going to continue going down 2 over 1, down 2 over 1, down 2 over 1. And we can draw this line. And again, I don't need that vertical line. That was just to show you guys that we wanted the right side of 2. And I don't need those first 2 points because those were less than 2. So this is the graph of this piecewise function. So I'd say, what you could do this. You could say, well, what is f of 1? And so you'd look here and you'd say, okay, well, f of 1. Well, which constraint does it fit? Is 1 greater than 2? No, 1's less than or equal to 2. So I'm going to plug it into this first equation. So that f of 1 would be 3 times 1 minus 7. What's 3 times 1 would be 3, and 3 minus 7 is negative 4. So we're saying the value of my function at 1 is negative 4. That's the point 1, negative 4. So we can look and we can see, hey, at 1, look at that, the value of my function is negative 4. Now the only thing that we have trouble with is at 2. So at 2 we can see we've got an open circle and a closed circle. So our answer or our solution would be at 2 the value of my function is negative 1 because I have the closed circle here. The open circle means we go close to 2 but we have to be bigger than 2. So that's how we show it that we're going to use an open circle there. So you guys should try this. And here's what you do. Let's call the top one our blue function. Now this one we're talking again about being less than or equal to 2. So I'm not going to go past 2 on none of my x values are going to go past 2 here. Okay, so I'm not going to go past there. So my y-intercept is 4. Put a point at 4. My slope is 3 or negative 3, so I'm going to go down 3 over 1. Down 3 over 1, and so when I do this I go down 3 over 1, and because I have the equal sign here I'm going to put a closed circle here, and then I'm going to move the other direction because I'm talking about being less than 2, so I'm going to go up 3 left 1, up 3 left 1, and we'll draw our line. Okay, this isn't part of my graph, that was just showing that we're going to be at 2. We'll do the next one in green, and again green we want to be to the right of 2, but I still need to plot this y-intercept and then I'll erase it once I move to the right of 2. So my y-intercept is at negative 2 and our slope is 4, so we're going to go up 4 over 1. I'm not going to use that point either because it's still to the left of 2. We want greater than 2, so up 4 right 1 again. And now I want that point, but I don't have the equal symbol, so I'm going to put an open circle. And I'll go up 4 and right 1 here. And now the only part of my graph is going to be with the open circle. I'll erase my first 2 points because those aren't greater than 2. And that's my graph. Now we could do this again. What if I said, what's the value of my function at, well, let's say 2. So we look at the constraints, and which constraint does 2 satisfy? 2 satisfies the top constraint because of the equal symbol. So I have to use this one. So I'm going to say negative 3 times 2. We substituted in for x. Negative 3 times 2 is negative 6. Negative 6 minus 4 is negative 2. And so we should see, hey, that's the point. 2. The value of my function at 2 is negative 2. That's the point 2, negative 2. And there it is right there. Practical application for this. So we can see here where this is about a cell phone service, and it looks like monthly cost is here on the y-axis and total number of minutes is here on the x-axis. So I want to represent this part of my graph right here. So how could I represent this part of my graph? I'm going to say, well, this part of my graph is going to go, that's $20 and $40, so that's going to be $30. So f of x equals 30, and my constraint would be from 0 to 200 minutes. So from 0 to 200 minutes, and we'll say we're greater than or equal to 0 and less than or equal to 200. And now my next graph is going to be a little bit more difficult. That would be this one. And well, I can see my constraint, that's easy. We're going from 200 to 500 minutes. And so we're less than or equal to 500. And they go to the same point, so I'm going to say equal on both of these. And that's okay if they're in the same point. Now what is this graph? Well, to go from 200 to 300, we went from $30 to $60, right? So right here is $30 and up to 60. So my change in y is 30, and our change in x is well, from 200 to 300, that's over 100. So that's 30 over 100, or 3 over 10, or 30 cents for every minute. And I'm going to say 30 cents for every minute. No, I'm not, because I want to be able to continue this going down. Let's just hold off for that. So my slope is going to be 30 over 10, or 30 over 100, or 3 over 10, or 30 cents for every minute. But I need to figure out what a y-intercept would be. So we're going, down 30 for every 100 units that we go over. So I could continue this over, and I'd be over here at $0 for 100 minutes if I continued this line, and if we continued this line again, down 30 again, this would be negative 30, right? So my y-intercept is negative 30. So this equation is going to be f of x equals, and my slope we'll say is 0.3x minus 30. 0.3, so 30, that's 30 cents for every minute, or $30 for every 100 minutes. Our homework is homework 31.